In this video, I'll show you how you can use Xtract3D to model an impeller. As you can see, I've already imported the STL data, I've aligned it, and I have an axis that goes through the center of the part. The first stage is to use the slice tool to extract the geometry. So if I pre-select the axis and the front plane, then select the slice tool, I have the option to use enable multi-slice. I'm going to set the angle to 360. I'm going to give it, say, 36 slices, so one every 10 degrees. And as you can see from this preview, this is where all the slices have been taken through, but they've all been projected back onto the front plane, which gives me a nice definition of this edge of the blade and the hub of the impeller. For the next stage, I'd like to extract the blade surface. I'm going to do this very simply by drawing 3 splines across the surface, one at the root, one down the middle of the blade, and then one along the tip. So I can start by hiding the slice information to start off with, and I'm going to select the create entity, change that to spline, and now I can just pick off points on the mesh. For this next bit, I'm going to use a surface as a guide. So if I just show my sections here, what I've done here is I've created a spline which just goes through sort of the center between the tip of the blade and the hub of the impeller. And if I revolve this surface rather, it will give me a guide to where I place points for the middle of the blade profile. So again, I'm just going to hide this slice data. I can now hide that surface, and I'm going to repeat the process for the outside spline profile. Now I'm going to use the loft tool to place a surface in there, and I can just do a very quick deviation analysis. That all looks fine for now. Close that. Because I picked off points within the blade profile, the surface ends up being a little bit small, so I'm just going to extend it out using the normal SOLIDWORKS extend surface tool. Let's make that 1 millimeter. I think that will be fine. And if I now thicken that, it looks like it's about 1 millimeter thick, so I'll leave it at 1 millimeter for now. That gives me the top and the bottom surface of the impeller blade. Next, I'm going to create the hub profile. Now, I'm just going to show the slices. To save time, I've already traced the profile. And I can revolve that round. I'm not going to merge it at this stage because I still want to trim the blade, but I now have the hub and the blade. And again, to save time, I've already traced the profile. If I now revolve that profile, oops, and use that insert, cut, with surface, and select that body. And if I go on to the next feature that I've already created, for this, I'll just hide my CAD data and just show the scan. I've literally just used the create entity tool because it's a 3D curve. It's just a single line and it's along that blade edge because I wanted to be able to trim this back along there. So I've placed a 3D sketch on there, and rather like the spline but with just a line, and I've then created a plane on the end of that. So I'm going to draw a sketch on that plane. Select that sketch and cut that through all. I think I'll just, for the safety, I will just go both directions. I'm going to select only the blade. Okay, now I can hide this. I'm going to put a radius across the front edge of that. 0.5. It's a nice close fit to the scan data. I can hide that. So now you can see I have one blade in its entirety. I can pick the circular pattern tool, select that blade. I'm going to select bodies. We have 7 blades. If I now hide the scan data, you can see that we have the 7 primary blades. Now to get the smaller blade, it's probably a part of this surface, but if it isn't, I would just repeat the process I previously used to create the outer blades. And that's how you can use Xtract3D to create an impeller.